Okay.
Good morning, sir.
Good morning. So I hope the FFT and all these things is okay. You have no doubt. And today we'll start the filter design. Now I make what is that? Anybody from Calcutta? So anybody from Calcutta? Calcutta से कोई है क्या? Okay. All right. So let me start filter design technique.
স্যার কালকে নোটটা পাঠান।
কালকে ওটা আজকে পাঠিয়ে দেবো, কালকে নোট অ্যাসাইনমেন্ট ওটা আজকে পাঠিয়ে দেবো, আজকেটা আজকে পাঠিয়ে দেবো, ঠিক আছে? কালকে পাঠানো হয়নি, ঠিক আছে?
গুড মর্নিং স্যার।
গুড মর্নিং। আজকে সব দিয়ে দেবো, নোট এবং ক্লাস নোট। আর কালকে টুমরো there will be no class, means Zoom class will not be there, but still I will send some note and that thing in later part. Okay. But Zoom lecture tomorrow I will not take because the co-cube student having test from 10 onwards and they can give test up to 3 p.m. So within that they have to complete 3-hour test. All right. So for that reason it is not possible for me to get class tomorrow. And also there may be some problem in the students, so I have to look after. So tomorrow I will not take Zoom class, but I will give you the notes and assignment. And today I will send the notes for today and yesterday at the same time assignments. Okay.
স্যার প্লেসমেন্ট সিজনে এখন কোনো এক্সাম নেই?
প্লেসমেন্ট সিজনে
এখন এক্সাম নেই তো?
এখন এক্সাম নেই। এখন যে ওদের টেস্ট ফেস গুলো আছে উইকলি সেগুলো দাও, ওখানে তো টেস্ট আছে না?
এখন কিছুই নেই স্যার।
এখন কিছুই নেই? ও ঠিক আছে, আমি খোঁজ নিয়ে দেখছি এটা কি করা যায়, ঠিক আছে? কারণ প্র্যাকটিস ইজ রিকোয়ার্ড। হোয়াট ইজ দ্য প্রবলেম ইন co-cubes? Direct giving test, no practice. That is the problem in co-cubes, you know. But placements actually for giving test it require practice. Anyway, I have given ID to 6-7 students, maybe 8-9 students also. Reference group ID, they can practice over there. Or they may share between other co-cube students because you require practice. Directly giving test is difficult. Anyway, we'll see. And placements is also I'll look after what is the test next round and all. Okay. Now let us start filter design technique. Filter design technique. Okay. So filter design means we will talk of FIR filter, right? FIR filter, finite impulse response filter. Previously, I have discussed while discussing the systems that FIR systems means finite impulse response system, right? Finite impulse response system. What I mean by that, number of non-zero samples in HN. HN is finite. Okay. Now, if I talk of a filter design, filter is essentially a system, is not it? Essentially a system. So filter is a system that is a frequency selective system or frequency selective device. That means it selects certain desired range of frequency and rejects certain desired range of frequency. Thereby, this is a filter, and filter is essentially a frequency selective device. And there are basically four kinds of filters. All right, basically low pass filter, band pass filter, high pass filter, and band stop filter. Right. Now, if I look into the filter as a system,
बीएसएफ টা কি বললেন?
band stop filter,
Stop.
band stop filter, that is low pass filter, band pass filter, high pass filter, and band stop filter. These are the filter actually we will discuss slowly under FI filter design. Now, before that, of course, we are discussing digital filters, FI digital filters. Okay. Now, if I look at filter as a system, then filter will have some impulse response. If it is finite, then you will be having finite number of coefficient in HN. And if I have certain input xn, and you will get certain output. Now, what is xn? Xn is the signal, right? Xn is the signal for which I have to select certain portion of the signal. Certain portion of the signal will be selected, rest of the signal will be rejected. So certain portion which is selected, that is the desired part of the signal. So output will be, so input is the entire signal, output will be desired part of the signal. And this part which is undesired, that will be removed by the HN. Okay. Now, suppose if we select a low pass filter, that means the low frequency portion will be selected, high frequency portion will be rejected. So when it is a high pass filter, then high frequency component will be selected with respect to a certain frequency, and lower part will be or less than that particular frequency, that will be rejected. That's a low high pass filter. Band pass filter means certain bands will be selected, rest of them will be rejected. Band stop filter means entire part will be selected except the stop band, right? So essentially filter is a system, frequency selective system. It will select certain part of the signal, and that will give you as the output, right? And xn is the entire signal, and this will be selected part, yn, and hn is the filter impulse response, which will be either low pass filter, band pass filter, high pass filter, or band stop filter. Now, if it is xn, then you will having the x of e power j omega, which is the discrete time Fourier transformation. Okay, h of e power j omega, that will be also discrete time dtft of hn, discrete time Fourier transform, and yn, that is having the Fourier transform y of e power j omega. Okay. Now, if a filter is selecting a certain portion of this signal xn, then output yn could be c to x of n minus alpha. What I mean, the part which will selected, the filter should not introduce distortion, or filter should not alter the signal as well. It is not altering the signal. It has to select as it is the desired portion. So what most we can expect in the distortion in the output, it may be shifted by some amount, or it may be multiplied by some constant. This constant could be positive or negative. Okay, so this constant is essentially a gain or attenuation, could be positive or negative also. That distortion we can allow, but more or less a output will be some constant time x of n minus alpha. What I mean by that, that a filter is essentially select the certain portion of the signal and reject the certain portion of the signal, which means that while selecting, it should not introduce any kind of distortion within that the selected region. What at most I can allow, maybe multiplied by some constant, positive or negative, and maybe shifted by some amount. Because if it is shifted by some amount, I can reverse it and I can again shift into the original position. Therefore, while selecting the particular section of the input, filter can give you at most the output C time x of n minus alpha, right? Okay, so Hn is the filter. It will select certain portion of Xn and it will reject certain portion. What I mean that while selecting the certain portion, it should not introduce distortion in that particular portion. Therefore, this output at most could be C times x of n minus alpha. Okay, now if I take the Fourier transform, this will be y of e power j omega, y of n, and C times x of n minus alpha will be C times x of e power j omega e power minus j alpha omega. So that one, if you look at the derivation, x of e power j omega, which is the Fourier transform of x of n equal to minus infinity x of n e power minus j omega n. Then if I want to find Fourier transform of x of n minus alpha, this will be x1 of e to the power minus j omega, which is equal to n equal to minus infinity x of n minus alpha e power minus j omega n. Then if I assume n minus alpha equal to u, then n minus alpha equal to u, I can substitute n equal to u plus alpha. I have substituted, n equal to u plus alpha. So this will be alpha plus u, n equal to alpha plus u. Now if n equal to minus infinity, u equal to minus infinity, agreed? N equal to plus infinity, u equal to plus infinity. Therefore, this is u equal to minus infinity to infinity x of u e power minus j omega alpha u. This is u. So this is equal to e power minus j omega alpha if I take outside. Otherwise, this is u equal to minus infinity x of u e to the power minus j omega u. This is equal to x of e power j omega, which I mean that if x of n equal to having Fourier transform, discrete time Fourier transform x of e power j omega, then x of n minus alpha, that will be having Fourier transform e to the power minus j omega alpha into x of e power j omega. Is it all right?
Yes.
Good. Now, this is equal to y of e power j omega, c into x of e power j omega e power minus j omega alpha. Therefore, if you look at the transfer function of the filter, that will be y of e power j omega, x of e power j omega, ratio of this. What I have said previously, that transfer function of a system is nothing but output of the Z transform or Fourier transform and the output of the Z and the input of the Z transform or Fourier transform. That ratio is known as the transfer function. And if you take the inverse of that transfer function, that will give you the impulse response of the system. Okay.
Yes.
So by and large, what I'm saying that a filter having transfer function of this kind, C into e power j omega alpha. I repeat that C could be positive or negative. C could be positive or negative. That if it is positive or negative, that is not an issue. We can alter this. However, if the signal is changed by internally, if it becomes suppose say x of 2n or x of n square like that, then signal will get altered. If signal gets altered, then filtering does not have any meaning, because filtering is intended for selecting certain portion of the signal. But while selecting that particular portion, we should not introduce distortion or alteration. Therefore, the selection should be unaltered version as far as practicable. There may be certain shift, that is not a matter, and if it is multiplied by some constant, that is also not a matter. However, other than that, we don't want any kind of distortion in the existing signal. Okay. Therefore, if there is an alteration in the signal itself, then filtering does not have any meaning. because you have got totally different signal, then it is not a filtering. So filtering essentially means the portion we will select, that portion should be as far as possible unaltered. All right. Now if I find the magnitude of the filter response, so h of e power j omega equal to c for all values of omega, which means the magnitude is constant for all values of omega, and angle of this will be alpha omega minus, which means that amplitude is constant for all values of omega, and the phase of the h of omega is a linear function of omega. This is called linear phase characteristics. So linear phase characteristics is essential for a phase system, right? And these characteristics will ensure the unaltered extraction of the desired portion of the signal from a given signal, and therefore this will justify the term filtering as a true sense. Okay, therefore linear phase is the one of the important criteria of FIR filter. Okay, we'll discuss in detail what is linear phase and how do you linearize a filter transfer function. Now I'm writing that hd of e power j omega. hd of e power j omega means, suppose some desired filter response of e power j omega means hd of n. hd of n is your impulse response of the filter, ideal I'm talking about, and it will be having the Fourier transform hd of e power j omega. Desired means ideal. Now they are related by this. Now what is the hd of n? hd of n equal to 1 by 2 pi minus pi to pi hd of n. This is the Fourier transform, and this is called inverse Fourier transform. This is the relation. Now a question may arise, why integration? This is because hd of e power j omega is a continuous function of omega. Yes. Since
Yes.
it's a continuous function omega, you can find integration, you can go to differentiation, everything could be done. Since it is a continuous function of omega. Okay. So now if you look at this equation, you will see that hd of n, the limit is minus pi to pi. The reason being, limit minus 2 pi to pi, you know that hd of e power j omega, hd of e power j omega is a periodic function of omega, right? So if I want to calculate hd of e power j omega plus omega equal to omega plus 2 pi, then I will get n equal to minus infinity hd of n e power minus j omega plus 2 pi into n. This I can write n equal to minus infinity hd of n e power minus j omega n, because e to the power minus j 2 pi n equal to 1. Because e to the power minus j 2 pi n equal to cos 2 pi n minus j sin 2 pi n, this will be equal to minus 1 to the power 2n. Minus 1 to the power 2n, and therefore this is equal to 1. What I mean by is that hd of e power j omega, this is a periodic function of omega with period 2 pi, and it is a continuous function of omega. This is the two observations which I have discussed earlier as well. Now, keeping this in mind,
Sir?
that tell me.
স্যার বলছে ওই সেকেন্ড লাইনে যান না উপরে
এটা এটা
না স্যার
এটা
হ্যাঁ এইচডি অফ এন স্যার এই দিকটায় মানে এটা এইচডি অফ ক্যাপিটাল এন হবে না স্যার?
এইটা কেন? আমি তো বলছি
মানে
এইটার,
না না স্যার নিচের লাইনটা স্যার
আমি এইখানটায় বসাচ্ছি তো, আমি এইটাতে বসাচ্ছি এই ইকুয়েশনটা তো। The equation is the hd for j omega তে আমি omega equal to omega plus 2 pi বসাচ্ছি, তাহলে এখানে আমি omega equal to omega plus 2 pi বসাচ্ছি। কেন ক্যাপিটাল হবে? এটা ক্যাপিটালই তো আছে, এটা ক্যাপিটাল আছে।
সেকেন্ড লাইন, the second right hand side,
এইটা
right hand side, হ্যাঁ স্যার
এইটা
right hand side স্যার RHS
কারেক্ট, ইয়েস, এটা ক্যাপিটাল আছে,
ওটাই বলছি।
দিস ইজ হবে hd of e power j omega হবে, এটা ভুল আছে, কারেক্ট, ইউ আর কারেক্ট। এখানে এইটা হবে, তাই না? তাহলে এটা হবে hd of e power j omega, yes you are correct, I will correct this, good, yes correct, so hd of e power j omega এই জায়গাটায় হবে, correct, okay, but see this is hd of n, this will be written as hd of e power j omega, correct. Now once we have this, then what we have got, that hd of e power j omega is a periodic with period 2 pi. Is it all right? And 2 pi, so if I say 2 pi is an interval, right? 2 pi is the interval means that any interval of 2 pi, any interval 2 pi minus pi to pi, this is also interval of 2 pi. 0 to 2 pi is also interval of 2 pi. Now, this formulation hd of n, that is given minus pi to pi hd of omega equal. So here the limit of omega, that is minus pi to pi. So what I mean that the range of vision has to be minus pi to pi, and this is due to the fact that ht of e power j omega is a periodic function of omega with period 2 pi. Okay. Now low pass filter, essentially the negative frequency in practice has no use, but the thing is that if you are using the Fourier transform equation, then you have to consider the negative part as well. Now, essentially my low pass filter in practical sense 0 to omega c is the cutoff frequency. So it will pass the signal 0 to omega c, and beyond omega c it will cut off. Now see, my range of vision is minus pi to pi because it's a 2 pi interval. Now, for mathematical point of view, I will consider minus omega c as well. But when we design practically, we will consider only up to 0 to pi. Okay, 0 to pi, and we should have the response as far as possible like this. Okay, so this is the response, ideal response of low pass filter. Now, if you look at high pass filter, this is omega c to pi. Pi is the maximum limit as far as digital frequency is concerned, and my vision is minus pi to pi. So omega is c to pi. This will be the high pass filter, and minus omega c to minus pi. This is the negative counterpart of this, and the signal, it will be start passing from omega c and pass up to pi. Okay, and band pass filter, that will be passing certain band omega c1 to omega c2, and this is the negative counterpart, but we will practical design only omega c1 to omega c2 we will design. So omega c1 to omega c2, this is the band it will pass, and this is the band stop filter response, ideal band stop filter response. This will be stopping this band and passing all other bands like minus omega c1 to plus c1, that is passing omega c2 to pi, and minus omega c2 minus pi. These are all the pass bands, and this is the band omega c1 to omega c2, it will not pass. So this will be the band which you want to stop. So I will be passing entire band except this omega c1 to omega c2. What I want to mean now, that if I design a filter with some desired response, so I will assume this is the desired response. So for a filter, practical filter, if I assume, if I are supposed to design, then I should have a desired response. What kind of response is desired? This is the desired response for low pass filter. This is the desired response for high pass filter. This is the desired response for band pass filter, and this is the desired response for band stop filter. So now there is two things at this stage. One thing, that we are designing a FIR filter. FIR filter means I have to ensure linear phase. This is the first criteria. Second thing I have to see, I am designing a FIR filter, means my filter coefficient should be finite. But if you look at this equation have infinite number of terms, and if you find hd of n, here also you will be having infinite values of n. All right, okay, but we have to find the finite number of values from the set of infinite number of values. This is the second task I have for a FIR filter design. The first thing, I have to ensure linear phase. Second thing, I have to make it finite by some technique. Two things we have to understand at this stage. So I will assume what kind of filter I have to design. I have to assume that particular ideal response. Then I have to start designing. Whilst designing, I have to keep track linear phase, at the same time finite number of filter coefficient. Finite number of filter coefficient. Okay. Now with this understanding, let us look at how to make it finite. Now hd of n is the impulse response of the desired filter. Now this will be having infinite number of values, right? Because this will be having infinite number of values. Now I have to select certain window function. Now window function I am naming it as a say rectangular window. Rectangular window that is having values say 0, 1, 2. These are 3 value, and hd of n having infinite number of values. Now if you multiply these two, hd of n wn, now hn is the filter response that is obtained, that will be having value 0 to n minus 1. If I have wn equal to 1, 0 to n minus 1. So that means 0 to n minus 1 for this particular example 0, 1, 2. So n equal to 3. N equal to 3. So 0 to 2, I am having wn equal to 1. If I multiply these two, I will be having hn is jdn multiplied by wn, that will be having response 0 to n minus 1. Agreed?
স্যার ক্যাপিটাল এনটা কি ধরা হয়েছে?
ক্যাপিটাল এনটা হচ্ছে গিয়ে নাম্বার অফ পয়েন্ট। ক্যাপিটাল এনটা হচ্ছে নাম্বার অফ পয়েন্ট ইন wn।
উইন্ডো সিগন্যাল মানে কতগুলো নিচ্ছেন?
আমি এখানে 3টে নিয়েছি, কিন্তু এটা ইন জেনারেল 5টা নিতে পারি, 7টা নিতে পারি, 10টা নিতে পারি, ঠিক আছে? এইবার যেহেতু আমি এখানে 3টে নিয়েছি, সেই কারণে আমি n এর ভ্যালুটা এখানে লিখিনি, কিন্তু এই পার্টিকুলারের জন্য ভ্যালুটা কত হবে যদি এটা বলো, তাহলে হচ্ছে n ইকুয়াল টু 3। n ইকুয়াল টু 3 কেন? কারণ হচ্ছে কি n মাইনাস 1 কত হচ্ছে এখানে 2, তাহলে 0 থেকে 2 মানে 0, 1, 2, তো wn হচ্ছে 0, 1, 2, 0, 1, 2 তিনটে। wn এ যে তিনটে ভ্যালু থাকে, নাও ইফ আই wn টাকে যদি hdn দিয়ে মাল্টিপ্লাই করে তারপরে যদি আমি সেটাকে বলি hn, তাতেও কটা ভ্যালু থাকবে? তিনটে ভ্যালু থাকবে।
তিনটে।
তাহলে এখানে তিনটেটা একটা পার্টিকুলার এক্সাম্পল, কিন্তু এটা 5টা 7টা 10টা যা কিছু হতে পারে। সেটা তোমার প্রবলেমে দেওয়া থাকবে যে কটা পয়েন্ট নিয়ে আমাকে ডিজাইন করতে হবে, সেটা তোমাকে বলতে হবে যে আই এম ডিজাইনিং উইথ হাউ মেনি স্যাম্পলস। That will be specified in the particular problem. Therefore, this is an generalized approach. That's why I have written n. N could be, for this example, n equal to 3, but n could be 4, 5, 6, 7, 8, 9, anything. That will be given in a particular problem that you have to design with that many number of samples. Okay, but hd of n, that is infinite number. Then how do you make it finite? Depending on this window function. Window function means it's a small window that will convert a infinite signal into a finite one. Agreed? Okay. Now, if it is your h of n, then if I have h of n means if I want to find that h of n equal to how much, then suppose if I have n number of points, hn টাতে কটা পয়েন্ট আছে? 0 to n minus 1, তাহলে n, তাহলে h of e power j omega টা কি হবে? h of e power j omega টা হবে hn into e power minus j omega, n equal to 0 to n minus 1. Okay, so that I can write h of e power j omega, that I can write h of omega as well. Now I said that h of e power j omega, which was initially c times e power minus j alpha omega, I have written here c. If you have seen here that a filter could have this kind of response, c, so the magnitude of this equal to c. Okay, but I said that c could be positive or negative, but magnitude is always positive. So what I can write here, I'm writing that first I have got h of this equation, then I am writing h of e power j omega equal to plus or minus magnitude h of e power j omega e power minus j alpha omega. This is the requirement for linear phase. This is the requirement for linear phase, and this is the requirement of finite, right? This is the requirement of finite. This finite thing was done by this window 0 to n minus 1 multiplication. While multiplying hd of n, which is infinite in nature, if I multiply by wn, then this will get hn will be finite. So finite thing will be taken care by this step. Now I have to take care the phase linearization or linear phase characteristic. What I have seen in the filter, that h of e power minus j omega should be plus or minus magnitude h of e power j omega j power alpha omega. It was c in the previous page, but c equal to, I said this the magnitude could be positive or negative, it doesn't matter. So I have written plus minus magnitude h of j omega. Okay. Now h of j omega equal to this and h of j omega equal to this, e power j omega to this. Now I am equating both the things. If I am equating both the things means I have introduced that particular characteristics as well. Hello? Okay? Okay? আমি একটু ক্লাসে আছি, পরে ফোন করব একটু। Okay. So what I am saying that hn e power minus j omega n equal to this. So in this step we have taken care of finite response. This step linear phase criteria is there because this phase is linear. If I am equating both the things, that means we are introducing both the criteria together. Now if I see that e power minus j omega n equal to cos omega n minus j sin omega n, and e power minus j alpha omega equal to cos alpha omega plus j sin alpha omega. Now if I equate the real and imaginary part, then what I get, n equal to 0 to n minus 1 hn cos omega n plus or minus this. So I am equating the real and imaginary part. So n equal to 0 to n minus 1 hn cos omega n, that is equal to plus or minus h of e power j omega cos of alpha omega. Okay. Now n equal to 0 to n minus 1 hn sin omega n equal to plus or minus h of e power j omega sin of alpha omega. This is coming from this imaginary part. This imaginary part I am equating with this imaginary part. This real part I am equating with this real part. What I have got like this. Now once we get this, I am taking the ratio sin of alpha omega cos of alpha omega. Sin of alpha omega by cos of alpha omega, if we take, this will be divided by this divided by this. So you will get something like this. Okay. Is it all right? If I divide this by this, so you will get sin of alpha omega cos of alpha omega. Then it will be getting sin of omega n by cos omega n hn n equal to 0 to n minus 1. All right.
Yes, sir.
Now what we will do, I am multiplying this sin of alpha omega with this part, and hn this part I am multiplying with cos of alpha omega. Then simplify further, I have got this. Then if I take this part within the summation, then if we simplify, we will get h of n sin of alpha minus n into omega. See, sin of alpha omega n equal to 0 to n minus 1 hn cos omega n, cos of alpha omega n equal to 0 to n minus 1 hn sin omega n. If you cross multiply, you will get this. Now hn cos omega n sin of alpha omega I have taken here. Then hn sin omega n I am taken here cos of alpha omega. Now I am writing n equal to 0 to n minus 1 h of n sin of alpha minus n omega equal to 0. Now what is alpha? Alpha is the linear phase. Now I have to relate this alpha in terms of filter coefficient. What is n? N is actually the filter coefficient that we will be designing with. Okay. Now I have to relate with alpha with the filter coefficient. Now what I am assuming, let us assume alpha equal to n minus 1 by 2. If I assume alpha equal to n minus 2, then what happened? hn equal to sin of alpha minus n into omega, that is equal to hn equal to sin n minus 1 by 2 into omega, because alpha equal to n minus 1 by 2. Now if I write alpha equal to n minus 1 by 2, then if I simplify, suppose say n minus 1 minus 2n. Well, n minus 1 minus 2n by 2 equal to 2 into omega. Now this has to be 0, equal to 0. Okay. When this will be equal to 0, if I write n minus 1 minus n equal to n, if I write n minus 1 minus n, see n minus 1 minus 2n, I am writing n minus 1 minus n minus n. Now when this will be equal to 0, when n minus 1 minus n equal to n, then this will be equal to 0. So this term will be equal to 0 when alpha equal to n minus 1 by 2 and n equal to n minus 1 minus n. So this is the one solution of this particular equation. Right. So alpha equal to n minus 1 by 2 and n equal to n minus 1 minus n. For this particular situation, this equation will be 0. This is one solution. Maybe there are many other solutions as well for this equation, but this is the one solution as far as this particular thing is concerned. Now if n minus 1 minus n n minus 1 minus n, then I will write, if I apply hn, it will be equal to hn into equal to h of n minus 1 minus n. So this is the condition. This will ensure finite number of response and at the same time linear phase in the system. So this condition is very important. So what I am saying, that with this understanding, what I have done, that I have said that linear phase is an important criteria. So linear phase is an important criteria because due to the process of filtering, or in the process of filtering, there should not be any distortion or change in the signal which I am filtering, which is the desired portion. So to negate the change in the desired portion, we require linear phase, right? This is one thing. And second thing, if we are working with a FIR filter, if we are designing a FIR filter, then my number of filter coefficient has to be finite. That is done using windowing technique, and the phase linearization is achieved by assuming alpha equal to n minus 1 by 2. Now, why alpha equal to n minus 1 by 2? The reason being that n is the number which is known to me, because I have to design with the desired sample. The set will be given. So number of sample is given. So on all the problem I will be designing in a FIR filter, the number of samples will be given. So n is a known quantity. When n is a known quantity, I can always find alpha. At the same time, I have found a relationship in the impulse response that h of n equal to h of n minus 1 minus n. If this condition is followed, in such a case, my desired filter will be having a linear phase, right? So with linear phase and finite number coefficient, we should be in a position to design a FIR filter with linear phase. Now a question may arise in this, that why not infinite? Because it's a finite number, it is a FIR filter. And another important thing at this stage, that alpha equal to n minus 1 by 2, that is one condition, but with only this condition it will not be satisfied, right? This will be satisfied along with this h of n minus 1 minus n. n equal to n minus 1 minus n, that is this condition also requires similarly. Now for example, suppose n equal to 5, n equal to 5, okay, capital N equal to, তাহলে কি হবে বলতে h of 0 টা কি হবে বলতে h of 0,
H of 5 বললে 4 হবে তাহলে
H of 4.
h of 0 equal to h of 4, আর h of 1 equal to
5. H of no.
H of
3.
1
H3.
H3.
h3,
H of 3.
আর h of 2 equal to
H2.
1 H of 1 হবে
হ্যাঁ কেন
H of 2.
h of 2,
H of
then the
2.
same thing. Therefore for n equal to 5, h of 0 equal to h of 4, h1 equal to h3, and h2 equal to h2. So therefore with this kind of assumption, I can ensure the linear phase in the FIR filter. So next class we will discuss, next class means I will be having class in Saturday again. So that I will give you notes probably tomorrow also, but I will discuss next Zoom class will be Saturday. So next Zoom class I will find that for different values of n, when n is odd, n is even, then we will take some examples of practical cases when we will show you then why this phase becomes linear. Phase becomes linear means phase of the transfer function will be at the form of minus alpha omega, right? So I hope you have understood. If you have any doubt, you can ask.
স্যার বলছি হাই পাস ফিল্টারে আমরা তো জানি কাট অফ ফ্রিকোয়েন্সি থেকে বেসিক ফ্রিকোয়েন্সিটা পাস করবে, কিন্তু এখানে ওই ওমেগা সি থেকে পাই পর্যন্ত নিলাম না।
ওমেগা সি থেকে পাই পর্যন্ত কেন নিলাম সেটা কোশ্চেন। তো দেখো হাই পাস ফিল্টার মানে তোমরা
মানে
বলছো যে যে ফ্রিকোয়েন্সিটা বেশি তার
ওমেগা সির উপরে
পাস করবে, কিন্তু
হ্যাঁ।
ম্যাক্সিমাম ফ্রিকোয়েন্সিটা হচ্ছে পাই, বিকজ আমার এটা হচ্ছে 2 পাই এর পরে পিরিয়ডিক, তাহলে আমি ইন্টারভালটা নিয়েছি -π টু পাই, তাহলে -π টু পাইটাই হচ্ছে ম্যাক্সিমাম, তারপরেরটা কি সব রিপিট করবে, বুঝলে তো?
আচ্ছা
ফিল্টারটা তো 2 পাই এর পরে রিপিট, -π থেকে পাই এর মধ্যে যে রেসপন্সটা আছে পরবর্তী ক্ষেত্রে সেই জিনিসটা রিপিটেটিভ হবে, তো
আচ্ছা
সেটা তো অটোমেটিক রিপিটেড হবে, সেটা তো ডিজাইনের পার্ট নয়, তাই না? মানে ধরো এক্স অফ ই পাওয়ার জে ওমেগা, এইচ অফ ই পাওয়ার জে ওমেগা সমস্তটাই তো পিরিয়ডিক উইথ পিরিয়ড 2 পাই,
2 পাই
তাহলে -π টু পাই এর মধ্যে যা আছে পরবর্তীকালে তারটা রিপিট করবে বাই ডিফল্ট, তো সেটা তো আমার ডিজাইনের কনসিডারেশন নয়, তাহলে আমাকে ডিজাইনটা করতে হবে আপ টু পাই পর্যন্ত,
আচ্ছা
কারণ ধরো ফুরিয়ার ট্রান্সফার প্রপার্টি তো ওটা সব রিপিট করবে, তো সেটা তো আমার ডিজাইনে কিছু নয়, তাই না? আমি এইটুকু ডিজাইনে কনসিডার করবো, এবং প্র্যাকটিক্যালি আমি স্পেসিফিক্যালি